So my name's Andrew. I'm a PhD student at the University of Oxford, and I lead the Open Mind project. So we have a variety of initiatives going on. Our main focus is lowering the barrier to entry to privacy-preserving technologies in the context of COVID response apps. So there's a blog post listing our various projects that I will link to in the chat as soon as I finish chatting. So the main high level goal of these projects is to again lower the barrier to entry to various COVID related projects being able to do what they want to do while protecting data under computation. So there's a handful of projects, but we try to do this in a general purpose way. So when you visit our repositories, you won't necessarily find a bunch of like end-to-end apps happening there. What you'll find are individual components that are sort of generally useful within the context of a lot of different apps. So one of them is a private site intersection. So those of you who are aware or aren't aware, private site intersection is a really valuable component that allows you to sort of compare a set of things, say on a device, with a set of things on a server, and look for the intersection between these two. As it turns out, this is a very important, generally useful task, and private site intersection allows you to do it without either the server or client revealing anything about their sets to the other. So you can imagine, so one early relevance to COVID-related apps that this particular component was useful for was comparing GPS locations that someone's collecting on their phone with, say, sensitive GPS locations in the cloud of where patients have been in the recent history. So like the obvious application here being that you might want to figure out whether any of your GPS locations overlap with what has been stored in the cloud without necessarily having to upload all of your GPS locations to the cloud or download all the GPS locations from the cloud. But this has a variety of applications, including in Bluetooth contact tracing, which is not GPS based, for comparing hashes in the cloud to hashes that are on the local device. It's a really, really important use case. And the primary constraint is one is performance, so getting the algorithm right, and two is getting the algorithm working on as many backends as possible. So making it readily accessible for people who are running, Python or JavaScript based sort of central servers, as well as phones that might be running sort of React Native, which is JavaScript based, but in the React framework, as well as iOS and Android being super useful. So there's a whole project around that. Similarly, differential privacy is another sort of generally useful component, which is used for aggregating information to the cloud in a way that protects the anonymity of the individuals who create that information by adding a certain degree of noise. The big challenge with this library is or this technique is that there aren't very many robust libraries for doing it that have been really like road tested for security to make sure the implementation is correct. Google published one last year in August. This is C++. And so basically what we're trying to do on a sort of very short time scale is wrap this in all the different platforms that people might want to use it in so that they can use sort of the most secure and the most robust version of this library, which has already been deployed to many millions of devices, but inside of the environment, inside of Swift, inside of Kotlin, if you're doing it for Android, or Python, or JavaScript. So it's actually quite a challenging project, but extremely high impact from the standpoint that it's both extremely general purpose. Lots of apps are trying to aggregate data, for the benefit of healthcare providers, but doing so in a way that doesn't actually divulge individual row records is like super important. So those two, as well as another big effort going on, self-sovereign identity. So for those of you familiar with self-sovereign identity, this is obviously vital, but and there's a lot of apps for the wide variety of use cases that need it, but the barrier to people being able to leverage self-sovereign identity is still quite high. And so we have several projects. So these projects and more, I'll link the blog post in the chat. And yeah, I hope you have a great event, a great hackathon. And thank you for everyone who's participating.